Welcome to The Explainer. Today, we are going to untangle one of the most notorious topics in all of Java, handling dates and times. If you've ever written Java code, you've probably felt the pain. But stick around because we're about to make it all crystal clear.
All right, so here's our game plan. We'll kick things off by looking at the classic Java headache. You know the one. Then we'll dive into the modern Java.time solution. After that, we'll get practical with your everyday toolkit, learn how to master time zones, and wrap it all up with some best practices that'll save you a ton of trouble.
So first things first, let's turn back the clock a bit and understand why this has historically been such a massive source of frustration for so many developers.
I mean, come on, raise your hand if this has been you. If you've ever found yourself pulling your hair out over a weird, off-by-one bug in a month, or a time zone that just makes no sense, yeah, you are definitely not alone. For years, this was practically a rite of passage for Java programmers. So the old way of doing things, well, it revolved around these two classes, java.utilDate and calendar. And they were, frankly, a mess. For starters, they were mutable, which means their values could be changed after they were created. In a multi-threaded app, that's an absolute nightmare that leads to some of the hardest bugs to track down. And the API itself was just confusing. Who could forget the infamous zero-indexed months, where January was 0, February was 1? It was a constant recipe for errors.
But then, everything changed. Java 8 came along, and with it, a complete, beautifully designed solution that pretty much fixed all of these legacy problems in one fell swoop.
You know, for years, the community basically had to fix this themselves, relying on fantastic libraries like JodaTime just to get work done without going crazy. The arrival of Java 8 was a huge turning point. It took all the best ideas and lessons learned from libraries like that and built them right into the language with the new Java.time package. Finally, a powerful, reliable native API.
So what makes this new API so good? Well, it's built on a few really smart principles that directly fix the old problems. First up, immutability. This is huge. Every single Java.time object is immutable, meaning once you create it, it can never be changed. That makes them automatically thread-safe. Poof! A whole category of bugs just gone. The API also has real clarity. A date is a date. A time is a time. They're separate things. And it uses this fluent style that lets you chain methods together, making the code read almost like a plain English sentence.
Okay, theory is great, but let's get our hands dirty. Let's look at the actual classes you're going to be using day in and day out. This is your practical, everyday system.
First up, we have local date, and it is exactly what it sounds like. It represents just a date, year, month, day. That's it. No time, no time zone. It's perfect for things like a birthday, a national holiday, anytime you care about the calendar day but not the time on the clock. It's simple, and it's built for that one specific job.
And just look at how clean it is to use. This code is it's beautiful, isn't it? You create a date, and then you can do things like add 10 days or change the month. It reads like a sentence. And here's that immutability in action. When you call .+days, you're not changing the original myDate. You're getting a brand new object back. It's so much safer.
And right alongside it, we've got its sibling, local time. You can probably guess what this one does, right? It's just the time of day, hour, minute, second. Again, completely separate from any date. This is what you'd use for something that repeats daily, like setting an alarm or defining business opening hours.
And the same beautiful, fluent style applies here. If your office opens at 9 a.m., you can figure out the closing time just by adding 8 hours. The code is clean, it's totally readable, and there's no ambiguity.
Okay, so what if you need both the date and the time together? Well, that's exactly what local time is for. It combines a local date and a local time. But, and this is a really important but, the key word here is local. This class has absolutely no concept of time zones. It's just a point in time on a generic, unspecified calendar.
So this makes it perfect for things like logging an event on a server or scheduling a meeting, but only when you know for sure that everyone involved is in the same location. You don't need to add the complexity of time zones because, well, you don't need it yet.
But what happens when you do need to work across different regions?
For any application with users around the world, this is non-negotiable. And this is where the Java.time API truly, truly shines. So the API gives us some specialized tools for this. For machines, you'll want to use Instant. Think of it as a single, unambiguous point on the universal timeline, perfect for database timestamps. But for humans, you'll use Z-zoned time. This class is amazing. It takes a local time and anchors it to a specific zone ID, a real-world region like America/New York, and it automatically handles all the complex rules like daylight saving time.
So how does this actually work? Let's walk through scheduling a global meeting. We start with our simple local time date, 9:30 a.m. on June 6th. Then we anchor it. We say, okay, this meeting is happening in New York. That gives us our New York time. From there, the magic happens. We just ask Java, hey, what time is that exact same moment in London? And what about in Tokyo? Let's see the results. So here's our anchor. The meeting officially kicks off on June 6th at 9:30 in the morning, New York time. Now watch this. The API takes that New York time and correctly calculates that the same exact instant is 2:30 in the afternoon in London. All the complex time zone rules, daylight saving, it's all handled for you. No manual math, no looking up tables, it just works. And what about our team in Tokyo? For them, it's 10:30 at night on the same day. Think about that for a second. With just a few lines of incredibly clear code, you have flawlessly coordinated an event across 3 different continents. That right there is why Zone Time Zone Date is absolutely essential for building global apps.
Okay, let's wrap this all up. We're going to put it all together with a few simple rules of thumb to make sure you're always grabbing the right tool from your toolbox and writing code that is rock solid.
Really, the big takeaway is simple. Be intentional. Before you write a line of code, ask yourself, what am I really trying to represent? If it's just a date, like a birthday, use local date. If you need date and time, but it's all happening in one location, local timeline is your guy. If time zones are critical to your users, you need to use Z-Zone timestamp every time. And if you're storing a technical timestamp in a database, Instant is your best friend. Matching the tool to the job will save you so much grief. So by leaving those old, flawed tools behind and embracing this modern, clear, and safe API, you're not just writing better code. You're saving your future self from hours and hours of painful debugging. You now have the confidence to handle pretty much any date and time scenario that gets thrown at you, and you can do it correctly and elegantly.